We have finally reached the last video, which I thought there were 6 videos. There's actually 8, but this is the last video for 2.5, and this is just combining all of the transformations together. So what happens if you have an A, a B, a C, and a D? So first off, we're going to recap what each of these transformations does. A, when the A value is greater than 1, you get a vertical stretch. A, when the A value is between 0 and 1, you get a vertical shrink. Now I also want to recap, well, how do you do that from a point perspective? Well, whatever the A is, you always just multiply the A value by your Y value. So even if your A value is a half, you're still doing a half times Y. So the A value always gets multiplied by the Y value. What if the A value is negative? Well, you get a reflection of the Y values over the X axis. That point XY would now be a point X negative Y. All right, if you want to pause the video and keep filling out this chart, it's better for you than for me to do it, but I know sometimes people just like it when I do it. So what about the B value? When the B value is greater than 1, it's opposite. Your graph will be horizontally shrunk. How? Well, the B value, you always take the X value and you divide by it instead of multiplying by it. So if the B value is between 0 and 1, you get a horizontal stretch. And again, you know, this is kind of a tricky one. It's technically still X over B, Y, but we're looking at something like Y equals F of a half X. And so technically when you divide by a half, that means that you're actually multiplying by 2. So, you know, whatever sticks in your brain and makes it work. What about when the B value is negative? You get a reflection of the X values over the Y axis, so it just makes your X values negative. All right, horizontal shifts. This shifts where? Left, right? Opposite as it appears. You would always take your X and you subtract C. And again, this is confusing, but it's the key thing is it's the opposite of whatever appears here. So this is going to be a horizontal shift right. From a point perspective, it would still be X minus C. But here you have a C value that's greater than 0. So maybe put an example. So if you have Y equals F at X plus 3, then you get X minus 3. Whereas, so this one has a C value of negative 3, right? So it's subtracting. For this one, you'd have something like Y equals F at X minus 3. This one you have a C value of positive 3, so X minus 3, right? So it's the opposite operation. So maybe go something like this and be like, don't forget it's opposite. Same thing with B. Don't forget it's opposite. That's the key thing to remember. Okay, and then D, this is a vertical shift up. To get your point, you'd go X and then Y plus D. And then this is a vertical shift down, and this would still be X, and it would still be Y plus D, but you'd have a negative D value. Again, kind of, yeah, it's tricky to kind of say this all in one place, right? But if you have Y equals something like F of X plus 3, right, it's going up 3, whereas so this one has a D value of 3, so you'd be going up 3, whereas if you have something like F of X minus 3, your D value is negative 3, and so that makes it go down. Okay, right in there, whatever helps you do it. Now that we know what each of the things does and what value it affects, we have to look at it all together. So how many transformations are happening in this one graph? Hopefully you're thinking 4. The first transformation is this negative. So I always go in order from left to right. So this is going to be a reflection of the Y values over the X axis. In other words, you're going to multiply your Y value by negative 1. Second transformation is the 2. So what's the 2 going to do? It's going to vertically stretch my graph. my y values are going to get multiplied by 2. Now in reality, I do these two together and I just multiply my y value by -2. Okay, third transformation. Third transformation is my c. That's going to move it where? Right 2. So it's going to take my x values and I'm going to add 2. And then my last transformation, 4, is my d. It's going to move it where? Down 1. So my y values, I'm going to subtract 1. So how are we going to do this? Well, we have two options. Option number 1 is you can do it on your graph. You could say, hey, I'm going to reflect my y values first. So this point's going to come up here. This is going to stay here. This one's going to come down here. So I'm going to do this as a dotted graph because it's an intermediary graph. Then you could stretch it. Okay, so if I stretch it by 2, this point's going to come up to here. This point is going to come down to here. The zeros will stay the same. Ooh, if I've been smart, you know what we should have done? Let's do it with points too. So let's pick out these points. So -2, 0. We have another point 0, 0. We have another point at, oh, sorry, I missed a point. We have a point at -1, -1, 0, 0, 1, 1, and 2, 0. Okay, so we did the first transformation in blue. We reflected them, so we times the y value by -1. So this is the first transformation. We end up with -2, 0, -1, 1, 0, 0, 1, -1, and 2, 0. Okay, that was my first transformation. Then we'll go to green, and we're going to do these one at a time. Now I'm going to stretch it by 2. Stretch by 2, stretch by 2, stretch by 2, stretch by 2. So now I get that point -2, 0. I get -1, 2. I get 0, 0. I get 1, -2, and lastly 2, 0. So now I'm at this point here, right? I'm doing each of them one at a time. Now I'm going to move right 3. So this is my next transformation, or sorry, right 2. So I'm going to add 2 to all of the x values. Now maybe this is where I stop doing points. Maybe I plot these ones and then I'm like, hey, this is my green graph. I'm going to move it right 2 and down 1. Totally up to you. Or maybe we do it at the same time. Maybe you're like, hey, I can go right 2 and down 1 now. Let's do that actually. Let's go right and down because I can. Right and down, 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 down. So my new point is going to be 0, -1. So again, this point is moving right 2, check your scale, right 2, down 1. Then I'm going to move right 2 and down 1 again. So I get a point 1, 1. So I've got this point here at 1. Oh, sorry. I was like, I'm confused. I'm taking this point. The green graph is the left, so it's careful to color code. So I'm going right 2, down 1. So I get this point at 1, 1. Then my next point, right 2, down 1. I get a point at 2, -1. So I'm going to go 2, -1. And maybe now I like to connect them so I can show that this is that upper loop. And then lastly, I get 3, -3, which is moving this point right 2, sorry, I stopped doing that, right 2, down 1. And then my last point, I get 4, -1. So again, I'm taking this point going right 2, down 1. And then I can finish off my graph. So, you know, a couple things we could have done. We definitely could have just multiplied the y values by -2 and jumped straight to the green graph, right? I could have gone to the green graph and then taken it and moved right 2 and down 1 and not done it with the points. I could have just drawn nothing and then done all these points over here and finished with 0, -1, 1, 1, 2, -1, 3, -3, and 4, -1, and then just graph them. You know, it's kind of a choose your own adventure and sort of what you like. I know some people love color and they're just like, I want to graph more because finally math is feeling like art. And so they don't write any points down and they just transform and transform and transform. If you do that, please use other colors. Please make sure you show me which color is your final answer. You know, maybe like I should have done this green one in dotted lines, but I didn't need to. But maybe go, hey, this is my final solution, something along those lines, so I know what to graph. But you're looking that the graph has been reflected in the y values over the x-axis. You're looking that it's been stretched vertically by 2, that it's been moved right 2 and down 1. All right. Here's another one. I think I have 2. Oh, no, just this is my last one. So again, I'm sticking with one where I'm giving you the base function. I want you to first off write down and maybe pause the video and stop and write down what are the transformations going to be. Again, there's 4 transformations. So what are they? Transformation 1, reflection of y values again over x-axis. I could take it and I could do that with my graph. I can reflect my y values over the x-axis first, okay? That's going to take my y values and multiply them by -1. So my y values will become negative. Second transformation is that I have a what? What's this going to do? It's a horizontal stretch by 2. Going to take my x values and multiply them by 2. So maybe I have this reflected graph and then I stretch it horizontally by 2. My third transformation, yeah, I'll do them both in red. So my third transformation is that it's going to go left 2, right? So we're moving on to C. We go A, B, C, D. So my x values, I'm going to subtract 2. And then last one, because I'm going to do these 2 together, is this transformation, which is going to make my graph go up 2. In other words, my y values are going to be increased by 2. Okay, up to you. Again, I could do this without any points. I can reflect my y values. I can see it visually coming down. So this 3 goes to -3. This one would stay the same. And then maybe I take this point and go up to 3. So this would be an intermediary graph. Then I can stretch them by 2. So all these x values, this one at 3 would go to 6. This is a bit harder to see. This 1 times by 2 would go to 2. There's that point here. This 1 would go to 2, so I'm stretching all these x values by 2. This 4 would go to 8, and then that's all that would fit. It's so stretched out, right? And then I could move it left 2 and up 2. So if I take this graph and go left 2, up 2, left 2, up 2, connect the dots. Left 2, up 2, connect the dots. What's another nice point? This one? Is that a point? Yeah, it's a point. So I've got left 2, up 2, and then it keeps going. Oh, what about this nice point here? Left 2, up 2. No, that's the last one. There we go. That's my final graph. What if I was doing it with points? Okay, so let's start out by pulling out our key points. Our key points of this graph was -3, 1. The next key point here is at -1, 1. The next key point here is at 1, 3. The next key point here is at 4, 0. And you know, I don't think I actually need any more. Those are good. Okay, let's do the first transformation. First transformation I'm actually going to do together, so I'm going to do it in green. I'm going to do these 2 at the same time because they're affecting different variables. The key thing is you can do A and B together and then do C and D together. So I'm going to do A and B as one transformation. So I'm going to take the y values and I'm going to multiply them by -1, and I'm going to take the x values and multiply them by 2. So I'm going to get -6, -1. I'm going to multiply by 2, multiply by -1. I get -2, -1. I'm going to multiply by 2, multiply by -1. I get 2, -3. And then lastly, multiply by 2, multiply by -1. I get 8, 0. So I could double check, is this my green points? Do I have a point at 6, -1? Do I have a point at -2, -1? Do I have a point at 2, -3? And lastly, a point at 8, 0. Cool. Now I'm going to do these last 2 transformations together. I'm going to do C and D. Maybe I graph the green one and then I move it, or maybe I do it here. I'm going to go left 2, up 2, -8, +1. Left 2, up 2, -4, +1. Oh, those 4s. Left 2, up 2, 0, -1. And lastly, left 2, up 2, 6, 2. And then I check. So do I have a point at -1, 1? Yep. Do I have a point at -4, 1? Yep. Do I have a point at 0, -1? Yep. Do I have a point at 6, 2? Yes. Your choice. And if you're lost, I think less messy is points. I think more visual is taking the graph and moving it. You could do a combination. You could graph the green one, put it on there. Do the points with the red one, then graph it. You can do whatever you want, really. But I'm looking for this final transformed graph. And this is as hard as it gets. There's no other tricks. Okay. So what I want you to do now is go and practice. There's a couple worksheet questions. So ones where I've given you grids and I've given you the base graphs, and then there's a whole bunch of questions that you can practice in the textbook finally.